this computer.
Okay,
Okay, we are recording. We're good to go.
Great. So welcome everybody to this month's MESA Company Convo session. My name is Tom Ahn, and I'm the Executive Director of MESA here in California. I hope that everyone's been enjoying the series. I see a lot of familiar names. We're happy to see students returning each month. Please continue to share your feedback by completing the survey that we're going to post we're going to post a link to the survey at the end of the session. And also keep a lookout for all the monthly company convo invitations in your inbox. Next month is PG&E, and then the following month it will be Uber. Also, please share on social and give Alex, Brandon, and Mesa a shout out. I'm reading a script, obviously. A shout out using hashtag MESA Company Convos. During the session, feel free to use the Q&A or chat function to ask your questions. Don't be shy. This is your chance to ask questions in a low stress setting. So first, let's test this out a little bit. Can all of the student attendees say Happy Friday and add their school to the chat? There we go. It's working. Don't be shy. You're also going to be using either the chat function or the Q&A to ask questions. I'll be fielding those questions and sort of tossing them to our panelists along the way, so that we're going to get to that a little bit later in this session. First off, I want to introduce our esteemed panelists, Alex, Rosay, and am I saying that right? Rosay?
It's Rosay. It's Rosay like
Rosay.
wine.
Rosay. And Brandon Simmons-Rawls. Alex is a product manager at Zymergen. And as a product manager, he works collaboratively with software engineers and data scientists to develop tools that help predict what molecules can make sustainably through biology. In his role, Alex envisions the long-term roadmap of the product, and he helps drive execution of the short-term priorities and roll out new releases to biologists and chemists. He likes his role because it balances the technical knowledge he developed as a chemical engineer at Stanford, boo, and the high-level business strategy skills he developed as a management consultant at Bain & Company. Alex is originally from Los Angeles, and as the son of a Mexican immigrant, the mission of MESA really resonates with him. Alex was also a presenter and a mock interviewer during our Student Leadership Conference last fall. Brandon is a senior research associate at Zymergen, and as a senior research associate, he works within the lab, building and testing a variety of designs and different microorganisms to generate novel products. So they're going to get into what novel means. His work tends to be cross-functional and collaborative, so he gets the opportunity to interact with scientists, software engineers, project managers, and others. Brandon's specific role involves literature reviews of scientific papers, experimental design, strain engineering, assay and process development. I had to look up what assay meant, and there are two definitions, so I'm hoping that he'll illuminate us on which of those two definitions he's involved in. Data analysis, troubleshooting, and stakeholder coordination. His job requires to be agile and think in a fast-paced manner, to continuously research for unique solutions and suggestive ways of testing them. Brandon says he's fortunate to be able to combine his undergrad experiences in chemical engineering with graduate school experiences in molecular biology to add value to his work team. He has previously worked with MESA before at UCR. He was studying, and he's also been involved in some of our MESA competitions. And he's glad to be able to again support the program and be involved in what he thinks is a transformative endeavor. So can everyone please use chat to welcome Alex and Brandon? And as folks are doing that, why don't we have the two of you start us off by explaining what biofacturing is, and really get into depth about what Zymergen does. So Alex and Brandon, please take it away.
Yeah, we have some slides that we'll share that'll kind of cover what biofacturing is, what Zymergen does. So I'll go ahead and share these. While I'm doing that, to build on the introduction of Brandon, he also leads our career development resource group here at Zymergen, so has a ton of perspective too on professional development. And I'm sure I'll share some of that insight here today. So what we do at Zymergen is, rethinking biology, reimagining the world. Hopefully at the end of this talk, you'll have more perspective on what that means. I think Brandon and I put together a couple slides and pictures kind of, highlighting our journey. I'll hand it off to Brandon to, introduce himself, adding on to what Tom said, and I'll do the same after that.
Yes, thanks, Alex, and also thank you, Tom, for giving the introductions. So my name is Brandon. Of course, I work at Zymergen currently as a senior research associate. So I just put this slide together just to kind of give a idea, a little like snapshot into some of the major career milestones that I've had so far, but also throwing a little levity into it. So little baby Brandon, born in Georgia, long time ago. I am aging myself, but I graduated high school in 2009, then had the opportunity to engineer, graduated in 2013 and got my first job working with the Department of the Navy. And then while there, I was basically developing propellants and explosives for missile technology. But then I decided that I wanted to do some technology, so went back to get a master's in chemical engineering, but worked in a molecular biology lab. And that ended up leading me to my current role at Zymergen, where I can marry a lot of those different experiences together. And yeah, most of these pictures are just me in a lot of these different places throughout like the course of my experiences. So yeah, and I'll hand it off to Alex so that he can now introduce himself as well.
Cool. Less exciting pictures relative to Brandon. Also, let me know if my internet hops out at all. I think there's something I can do to fix it, but we'll see what happens. I grew up in Los Angeles and then headed up to the Bay for school, studied chemical engineering. I think as part of my education, realized, from the time I had in the lab to time I had at like engineering internships at companies like Dow, that I find the work of an engineer fascinating. I think you add a new piece onto the machine, and that's really cool. But while I think it's super interesting, I think for me, at least, I realized that the bigger picture, what world does this machine fall into? Where is it going? What other forces you have to consider in order for this machine to be a success? Help push me more towards being on the business end and now current product management end of these companies. I was able to leverage management consulting, which is kind of just answering a broad set of business questions. Some people say a doctor for businesses in some way. A few years at Bain that helped, during that experience, I got 6 months to work at any company I wanted. Worked at a company called Helix, which at the time was a small 23andMe competitor doing genomic testing, kind of being more on the business side of the organization there. Helped taught me that like being on the business side of organizations that are doing really cool science that I'm passionate about is definitely the place where I want to be. So I'm now a product manager at Zymergen, where I focus on tools to help our biologists and chemists predict what molecules we think we can make from biology and our biofacturing platform. So a little more on, I'm betting my career on the bio revolution. I want to kind of highlight why I'm excited about it and hopefully get you all excited about it. And I think with the long-term career goal of hopefully leading a company in this space. So I think 3 reasons I think this is an awesome place to be. And by this, not just Zymergen, I think the whole like bio revolution leveraging new technologies is one fascinating underlying science. I took here's a photo right here of CRISPR, which if you aren't familiar with, something that was just discovered 9 years ago, has already won a Nobel Prize. And it makes it really easy to genetically engineer not only microbes, but potentially down the line, human beings as well. So really powerful new technological advances that we've seen that, as you can see on the right-hand side here, is the cost of sequencing a genome, which at the time, 20 years ago when it was first done, was on the order of billions of dollars. And now today it's on the order of hundreds of dollars. And I think we're still just starting to be able to benefit from these incredible innovations in both reading and writing DNA. And what is going to be the impact of this? I think there's two main levers is going to help improve the world. I think the human health aspect, you can start to think about whether that's new therapies or being able to eradicate horrible genetic diseases. But actually what Zymergen's focusing on, and something that I think gets less attention for the power of biotechnology, is enabling more sustainable practices. Here at Zymergen, we partner with nature, engineer microbes to produce specialty chemicals. Imagine a chemical plant, right? High temperature, high pressure, toxic solvents. You don't necessarily want to live downriver from a chemical plant per se, but now picture fermentation or brewing beer. It's just, much more sustainable process, really leveraging the power of microbes, the power of nature to make really cool chemicals. And that's where some of the sustainable practices come in. And you can make a wide range of different things that I'll cover probably over the next 5 to 10 minutes. Cool. So diving in, what is Zymergen? Zymergen is a materials innovation company harnessing the power of biology to create novel materials with enhanced performance. And we really like to think ourselves at the intersection of this Venn diagram here, with sustainability on the left and performance on the right, because what we want to make doesn't just replace existing molecules that are made synthetically, but really find new and cutting edge molecules, either from nature or by putting pieces of nature and microbes together to create a whole new realm of products that are made sustainably. So how do we do this? I think we not only need a lot of biologists and chemists, but we have a really impressive technology stack as well, integrating robotics and machine learning and a lot of different data storage across what our biologists or chemists are doing, so we could iteratively learn, we can iteratively design the best microbes to make these new products. And why we're so excited about this? A lot of existing, chemicals, whether that's, plastic that you might have in water bottles or some of the nylon that you have in clothes, are made from a lot of different building blocks from oil. The barrel of oil, has your octane that you're using for gas, maybe some smaller hydrocarbons that you're using, natural gas or for other energy sources, but it has a broad range of different molecules that are the foundation for the chemicals industry and a lot of the materials that we see today. So if we're going to move off oil, we do not just do so from a transportation and energy standpoint, but we also need to do so from a material standpoint as well. And not only is this going to be a critical thing for sustainability, but by partnering with nature, as you can see in the image here, we get much more complex building blocks because nature has had billions of years to evolve in terms of what it's able to create naturally. So the molecules that we're able to get is going to enable us to create a broad range of sustainable products. And here's kind of a broad picture of different industries that Zymergen is either actively engaged in or thinking about. But here you see probably like 4 different categories of an industries to play in. One, you see agriculture pieces. There's conversations about replacing fertilizer with microbes that can serve a similar purpose. And there's healthcare. There's a lot of molecules. Think about penicillin that come from fungi. What are the other natural products that exist that could have therapeutic implications? Then there's a ton of consumer product potential as well, stuff that you'd see around the home. And there's a sunscreen product that's in our pipeline as well. There's an insect repellent product that's in our pipeline too. And then also there's other stuff, whether that's mining or sending in bacteria to almost extract out various chemicals. There's a lot that the power of microbes can do across these different industries to make better products more sustainably for a better world. And what you see here highlights on the complexity of biology. This is just every dot here is a molecule that exists. And I believe this is a map of E. coli, but basically when E. coli takes in sugar, converts it in all the different pieces that the cell needs in order to function, you can see these each as a starting point for a product or something that we can make through biology. And there's just so much complexity across different molecule types to lay the foundation for the broad range of different products we want to make, highlighting on the last slide. And we need a very big team to make this happen across a broad range of different industries: automation, bioinformatics, business development, chemistry, data science, fermentation, general G&A, finance, HR, legal roles, material science, microbe development, software engineer. So, across like different STEM roles, almost every single one can contribute to the mission that Zymergen has. Unfortunately, I think we're at the tail end of our current internship search process, but next year, early March, look out for that next wave of potential opportunities. There's, of course, like Tom said, we just IPO'd, so I think there's a new, there's a lot more like full-time opportunities that I imagine have just been posted as well. So definitely hop onto our career site, see if anything looks interesting to you. And I think I just have kind of more information on the internship program as well, kind of highlighting what the program is about, some of the more specific details. It's over the summer, you have to be enrolled in a program, and there's a lot of really cool opportunities to integrate with the Zymergen community as a part of it. In summer 2021, remote, but I imagine back in 2022, fingers crossed, things will be more on site. Cool. So that's the super quick overview of Zymergen, what we're about, what we're hoping to accomplish. Again, as I said, really complicated, but hopefully that made things a little more clear in terms of engineering microbes to produce a wide range of different molecules.
So thank you, guys. Brandon, did you have some other things that you wanted to add to?
Nothing specifically, but as we get some of the questions, I can add a few more insights. I think Alex did a really good job of explaining the company.
Great. So I have a couple really some questions. Like, what are you? I realize some of this you can't necessarily talk about, but what's been some of the most exciting projects or discoveries that you've been a part of, again, that you can talk about?
Yeah, so I think from my perspective, some of the most interesting projects or products are more related to like our novel, our novel products that we're putting out to market and how we're like attempting to make them. I think that when it comes to biology and biofacturing, people kind of view it as a binary where you either have things that are made completely from like petroleum resources or things like made completely from biological resources, but there is not a lot of emphasis on like the steps in between and how you can like marry them to eventually get from one side to the other. And one of the projects that I've had the privilege of engaging with kind of takes an approach where it's like you have this final product, but you can use different monomers in order to create it. So how do we like break that down into different steps to say, hey, we can produce like monomer A through a biological mean, and then like monomer B through a biological mean, and then find a way to marry them later on. But in that path, it might be like, hey, we do see like a step in order to improve like from just like pure chemical synthesis to like partial biological biomade products, and then just like keep inching that way. It's a lot less glamorous, but it is much more effective, and you can see like some of the measurable. Yeah, I think that was a very novel / exciting experience from me. But I'll also hand off to Alex.
Yeah, for me, one of my favorite projects, and now that we've publicly disclosed it, in some of our filings is this software called Zinc that I work closely on. It's the software that enables our biologists and chemists to see, like, here are the molecules we think we can make through biology, taking into account, the intuition of a biologist to forecast what we think we can make from microbes, as well as understanding from our chemists, what are the most important properties that you're going to down select for a specific application? How can we think about developing models to predict which of these bioreachable molecules, as we call it, will actually serve the purpose that we're trying to go after? So, and then of course, this is all backed by a software database, working with data scientists. So it really comes at the intersection of chemistry, biology, and software engineering that I kind of nerd out on that intersection day to day. So I definitely enjoy being a part of this very collaborative, cross-departmental environment.
Awesome. So it looks like we got a question from somebody possibly studying electrical engineering. This person wanted to know about sort of the opportunities for electrical engineers, and also about sort of the electronics applications of the products that you might create, because that's to me, that's a great question, because it doesn't seem immediately obvious where that might come into play.
Yeah, I think there's a couple of parts of that question. How an EE can thrive in a Zymergen environment, and then with regards to our electronics platform, which is one of our core businesses that we're trying to sell into, where does it even come in? So I'll start with the latter. So our first product, Hyaline, you can look and read more about it on the Zymergen website. It's a polymer with incredible properties, good optical properties, great, thermomechanical properties, meaning it can fold, it won't break, and with applications as one of the layers on a phone with a flexible screen, for example, as well as various other electronic, applications for where you need good thermomechanical and optical properties. So think of it as one of the main ingredients or layers that goes into, with many other ingredients that will eventually go into some sort of consumer product. And then for the first part of the question too, on the role of EEs, we have an automation team, and Brandon can talk more into how it helps enhance his lab work. But thinking through kind of how these systems operate, making sure they work effectively. And we also have a huge software engineering team as well. They reflect on my friends that I had who had EEs. A lot of them ended up going the software engineering route. So being able to contribute in that area too, with that background, I'm sure makes a lot of sense as well. And Brandon, I'll let you chime in if there's anything else.
Yeah, I don't think I have anything specific to add on the electrical engineering aspect. I think you're more, you're closer to that realm than I am. So I defer to your answers in that part.
Cool. So we got another question about a typical work day at your company. And I would imagine the answers are different for during pandemic, late stage pandemic, and then in a non-pandemic scenario. So what is, and you can maybe get into a larger question about company culture and norms and things like that might be interesting to our students.
Yeah. So I can take this one first. So when it comes to, pre-pandemic or likely post-pandemic as well, what my experience has been is that you work on a specific team that is centralized around a specific product they're trying to put out. For the most part, we would have, maybe bi-weekly, tri-weekly scrums, which is just to say there would be a small team meeting with any of the individual subunits where people give their major updates or inhibitions to their work. For example, if your experiment went really well and you have data, you just say, hey, I have data. You might go through it in that meeting, or you might just save it for a larger context. But you at least tell your managers or anyone that you're working with about these sort of things. Or if you have any issues, this piece of automation didn't work, there's a problem with this handoff, so that people are aware of it and it kind of helps coordination. After that, if you're working in the lab, a lot of it has to do with like daily coordination to make sure that you are planning out all your experiments, you are booking all the pieces of automation that you need if you do utilize them, and then it's more so going into lab. So for me, it can be anything from cloning different plasmids, working in different hosts, whether they be prokaryotic, eukaryotic. It can be just looking through a lot of academic papers for different ideas of what we can incorporate into our metabolism of something, or if we're trying to build out a molecular tool. And throughout the day, it will kind of vary because you'll have different types of meetings, things like that, to like inform different stakeholders, et cetera, et cetera. And then at the end of the day, it's usually just winding down and then recording a lot of your stuff in a manner that is readable by other people. The main thing for me that's changed between non-pandemic and pandemic times are just the fact that I still go on campus, but not everyone that I work with is allowed to. So more of it is like Zoom. We don't have like scrums anymore, but we will give updates via Slack, email, just so that everyone stays in the know as real time as possible. But we still have anything from, general team meetings. We still have employee resource group meetings and other things so that all the employees keep up to date.
Yeah, and to add on to that, as a product manager, I think I don't necessarily do any work myself in some ways as like actual lab work in the lab or writing code, but I see myself as a multiplier effect to make sure software engineers I'm working with focus on the most important things. In order to do that, what that takes for my own role is a lot of meetings to make sure I'm aligned with the software engineering teams, the different stakeholder groups we have throughout the companies, whether that's our departments of biologists and chemists, but also the more senior people within our technology organization to make sure we're all aligned on our short-term priorities. We operate in these 2-week sprints to make sure we're focusing on the top of mind things in a shorter time period, but also thinking through like what our quarterly milestones and priorities are as well to kind of give us that higher level guidance. So really just a lot of meetings to make sure we're all aligned on a short-term and long-term basis.
Cool. Again, another question about your software engineering team. I think someone wanted to know what tools or coding languages does your software engineering team generally use? And then actually, I have a follow-up to that after, as well.
Yeah, I imagine some of our open software engineering recs on our career site will provide the broad set of things that we use, but Python is kind of the go-to, at least with the people I work most closely with.
Awesome. Different answer from Brandon, or just you can just nod if it's the same?
Yeah, it's pretty much Python on our side as well, although a good number of people will say that it's less about what language you know and as opposed to the ability to code. Coding is more of a ability to learn and adapt and kind of apply some of that knowledge within like different coding settings. So even if you don't have experience with Python specifically, if you like have experience coding, it should be pretty reasonable to port some of that experience to like other things.
And I want to build on that quickly because Brandon's one of our biologists. He has to dabble with coding from time to time. For anyone else who's out there who's a biology degree, a chemistry degree, it doesn't have, coding as like a prereq or class you have to take. Always good to introduce yourself to the frameworks because there's so much data being generated from experimental activity nowadays that being able to write scripts and be able to parse that more programmatically is going to be something that you're going to see even if you're working on the lab bench.
Thank you, guys. So my understanding, at least on the early end, one of the things that made you guys unique was the way you conduct experiments using machine learning, and I think they called it brute force experimentation. Do you guys build your own machines, or I'm imagining like this, almost like like robots conducting experiments. Are these proprietary machines, or do you purchase your hardware from other folks?
So yeah, so when it comes to our automation, the vast majority of that is things that are already on the market that we can utilize. But there are also ways that we can configure those to expedite some of the work and make it more automated. So I believe if you have had the ability to watch like the Zymergen video, it's kind of shown in there like what's called a rack system, where you have a lot of interchangeable parts and they're able to intermingle. So you can have 6, 7 different units that you can just send certain samples to, and it does all the different processes that you need in order to run an experiment. And that helps with high throughput, because of course, like when you're doing something on a lab bench as an individual with like pipettes or whatever you're using, you can probably get through, let's say X number of samples. If you put it on an individual piece of automation, you might get 10 to 100x. But if you now allow that to be on a system, it can go to like 10,000x or something along those orders of magnitude. So some of our teams utilize that very much, and then we have basically a feedback system where anyone who wants to like upload a pretty standardized protocol kind of goes in, talks to our automation team, and then like works out the details to make sure that it can be onboarded to that system. I think that was the entirety of the question, but if I'm missing a part, please let me know.
Cool, thanks. We got another question about the data analysis team, and what you guys might be looking for in the hiring process for someone who wants to join as a data analyst. And actually, and beyond that, it'd be great to know if in general you hire folks with straight out of undergrad, or are you looking for folks with a couple years of experience, and you're looking for college students to do your internships?
Yeah, definitely looking for college students or students like undergrad and grad students for our internships. You have to be enrolled in one of those types of programs to participate in the internships. For full-time hires, there's some people depending on the role, we hire straight out of college, or we look for a few years of experience. I believe that information will be called out on the specific roles on the career page. I think for our data science team, which does a lot of our data analysis, it's kind of, people with either stats background or math background or certain like types of, I guess, experience deploying these types of machine learning or other types of algorithms is one piece of it. But I think the other piece of it that's critical for making this platform work here at Zymergen is at least some knowledge of what's going on either the biology end or the chemistry end, whether that's, something you minored in, or that's something you just took a couple classes in, or something you're just familiar with because of, reading up on the space and being able to speak some of that lingo. But I think that's something we definitely look for as we kind of build out our team, because it's critical to be able to translate what are the needs of our scientists into kind of what are the key questions they're asking, and then what are the implications of the underlying data analysis system that we need to employ to be able to get them that answer, and being able to at least kind of understand, both what's going on in the data analysis world as well as what's at least a high level going on in the biology or chemistry world is going to be critical for success at Zymergen.
Cool, thank you. this is a little bit more of a general question, but do you have what would be your advice to students, current students, thinking about a career in this realm, whether, during the pandemic or post-pandemic? You can even talk a little bit about, what you wish you knew as an undergrad that you know now.
Yeah, so I guess like to start off with the latter question, what do I wish I knew as an undergrad that I know now, is how multidisciplinary a lot of these roles or companies are nowadays. So you're probably not just going to be a biologist, you're probably not just going to be like a software engineer, you're going to have to kind of marry those two and, not be an expert in everything, but at least be able to be open to like communicating and learning at some level, like how to do a few different things. And it probably is a little bit more biased one direction than the other. I think for myself, it definitely behooves me as a bio learn a lot of the software and kind of technology in order to improve or expedite my work. And I think Tom kind of mentioned something in terms of like how we test or but it used to be called the radical empiricism in terms of approach, where we just like try everything, increase like the number of things that we can test, but that involves a lot of data management. So like from my side, I have to be able to kind of manage that. So the multidisciplinary, if I could say the word correctly, the multidisciplinary aspect of it is the first thing I wish I knew as an undergrad. The second thing is that your career is not going to be very linear. I think a lot of people just anticipate that you will figure out the one thing that you want to do, it'll be the same, and you'll just like go step by step, brick by brick until you get there. And I actually mentor high school students in the area as well. And one thing that I told them recently is that you should never expect that what you're doing now is necessarily what you're going to be doing in 10 years. And the realistic part of it is never going to be like a straight line, but it can be like a funnel where at the beginning you kind of just narrow it down to a few things that you're really interested in, and then from that you end up in like one or two roles. But then even at the end of that, it might expand back because you figure, hey, I really like biology for these 10-15 years, but now I want to do management, or now I want to do chemistry, and you widen your outlook and then kind of let it pan out to where you end up wanting to be. What was the first part of the question, Tom?
Wait 1 second.
Yeah.
Advice to current students.
Yeah.
When I think you
Yeah.
pretty much covered it. I think this idea of being acknowledging that the world is becoming more multidisciplinary and interdisciplinary, and so being open to like change and opportunities as they come. I think that's a great answer. Thank you.
Yeah.
Alex, did you have something to add to that?
Yeah, I think a couple of things that I would tell to undergrad or younger Alex would be, I think I majored in chemical engineering because I liked math and I liked chemistry. And I was like, oh, chemical engineering mixes the two of those together. I should have been focused on, what does a chemical engineer actually do? What does their day-to-day look like? Is this something I'm excited by? And the answer to that was no. So there's a lot of, quantum chemistry or very, fluid dynamics classes I could have avoided. Maybe I just take a biochemistry degree, learn the broader space, and then, focus more on either business classes or other extracurriculars. So having a sense of, okay, what does this role actually look like? Is this something I'm excited about? I think is definitely super important to think through. And I think the second thing I would talk about is the experiences you have in your extracurriculars, whether in like the leadership teams of those or helping, roll out various, student groups or programs or events are actually critical team building experiences that, you should definitely leverage in interviews that you have with places and try and go out and gather those as well. Because I think they set a foundation for you in a relatively risk-free way to just be more familiar with working with a broader set of people. That's only going to be helpful later down in your career as well. And I am more on the business end, but I'm sure Brandon can agree with those types of extracurricular experiences I've had sitting in a room, making decisions about, these types of undergrad events actually gave me the good enough reps to be more effective in a business and workplace setting for sure.
Cool, thank you. I know some folks are probably having to leave, but we're also still getting a lot of questions in. So for those of you who need to leave, please, Danielle's put the link into the survey. Please do our survey. It really helps us to understand what works for you and what doesn't in these sessions. So do the survey before you go, but we do have a couple more questions here. One was about internships. For a student applying for an internship, how do you stand out from other students? Are grades more important or experience? What do you think are things that make somebody a great internship candidate versus one that's just okay?
Yeah, so I'll tackle this first because I just got finished interviewing I think around 10 candidates for an internship for this summer and ended up selecting one. For me personally, and I think a lot of people would agree with this, it's more about experience than grades. A GPA, of course, looks nice, but what I'm more interested in is, hey, what kind of technical experience do you have? Have you been in a research lab? Or if you have a very high GPA, what were those classes that you took? Are they relevant to what I would ask you to do once you come on site? Are they lab based? Are you applying some of this knowledge? Things like that. And yeah, so I'll hand it off to Alex to see if he has some other insights as well.
Yeah, I think Brandon hit it on. Experience is critical because it gives people more confidence you can do this type of job. I think the way I see GPA, and I'm not in the hiring manager decision-making role for specific internships, but just thinking about, I think you want to be above a certain threshold, and I'm sure that threshold will depend about for whoever's looking at it, specific role, how competitive it is, but generally it's lower than you would think. And as long as you're above that threshold, then it comes down to, okay, checks the mark on GPA, does well enough in classes, but then they look at the experience, they look at what you've done. And I imagine, Brandon, you take someone, say, with a 3.5 who spent a ton of time in research labs and hands-on experience over someone with a 3.9 and very limited aspects of that, just because, they have the various reps. But just, the thing with this question is tricky, right? Because it's people making these decisions behind the scenes, and different people will put different weight on different things. So just keeping an open mind, trying to position yourself with experience for sure, and running from there.
Yeah. One other piece of advice, just really quickly, that I told to the high school students that I mentor, and just as another good piece of advice for looking for internships and full-time jobs, is that interest or genuine interest goes a long way. And from my personal experience, interviewing people who wanted to be interns, the ones that could speak about the company, and it seemed as though they did their research, knew what we were doing, and inquired about, oh, maybe 1-2 things that they read were really standouts, because it made it seem as though they would really appreciate the opportunity for an internship, and they kind of align with what we want to do. It's great to have someone who's very proficient at the things that you need, but I know from my personal experience, working with someone who wants to be there, who wants to learn, goes a lot further than someone who's just standing there because they kind of want an internship or they want to get paid.
Yeah, take that extra effort, highlight that you don't just want an internship, you want an internship at Zymergen.
Yes. Yeah.
Awesome. I think that's true of, if you're pursuing an opportunity at any company, like tell them why you want to be there specifically, not just that you want a paying gig. So I'm going to read this next question directly because I want you, there's probably a lot of nuances to that that you want to answer. For mechanical engineering intern / full-time roles, do you value someone with interest in engineering side or biotechnology by itself? And actually, my addendum to that question would be like, do your roles specify do you even say this is a mechanical engineering role, or how do you classify these internship opportunities?
Yeah, so I don't think there's anything that explicitly says like mechanical engineer, but our automation team would predominantly be composed of people who are like in electrical engineering, software engineering, mechanical engineering. So in looking at the question again, it's like, so would it be more engineering focused or biotech focused? I say Zymergen hires for a diversity of experiences. So while there is benefit to people who have interests or like some kind of experience with a biotechnology aspect, we also see like the benefits of having someone who has experience elsewhere, because it brings a lot of novelty to some of what we're trying to do, and having people think differently in those contexts brings us to like a better answer overall. And just to kind of give an example of that, even within biology, there are a lot of different places you can work, a lot of different things that you can do. I've worked with people who in their grad school experience have done like drug delivery, have done like, science around like the gut microbiome to see like what actually lives in your like stomach bacteria. It's like, oh, that's very crazy. And then my previous work was with yeast and yeast engineering, and then we all came together and make a team, and we were able to basically produce edited strains that were like like 50% improved on like our client strains to deliver to them. So hey, it works.
Yeah, there's a broad range of different opportunities and different roles. And even within like our automation team specifically, there's people who are like more going into the lab, seeing what our biologists do, brainstorming ways to like apply like, our robotics or automation technology to them. And then there's people who are more on just like the engineering end, actually developing those systems, building those systems, testing those systems that need to have less of a knowledge of biology. So definitely a broad set of, opportunities for people, and broad set of experiences that they've had. People come from like the semiconductor industry. I know someone who's come from like NASA, working in robotics there, for just an automation ecosystem. So there's a lot. I know we're approaching the final 5 minutes here, and I don't see anything else in the Q&A, but I kind of want to suggest a 2-minute Zymergen video that I think is pretty hype, and then we can wrap things up with some final thoughts.
Pretty
Cool.
hype. That sounds awesome.
That sounds great. The one thing I would love for you to address in your final comments is just, for underrepresented folks, especially in STEM, diversity and work culture can be really important. For women working in the sciences, can you talk a little bit about that and your experience with that throughout your career, but also most importantly at Zymergen? And then I'll let you go ahead and show this video. Danielle, do you need to give them permission? Oh no, you've already done that.
Yeah,
So.
I'll be good.
Okay.
Let's take this question on first. Brandon, do you have any quick thoughts to start us off?
Sure. So it is, from my professional experience, it is very difficult on a few different levels being a minority in STEM, because there's always that external factor where you're worried, like, will are people treating you fairly? Are people looking at you differently? Things like that. And there's also the internal conflict where you are like, am I living up to everything? I'm the only person in the room. Can I stand up for what I feel is right? And things along those lines. I will say it is definitely difficult, but one thing I try to do is stay grounded by going to a lot of different resources. So if your company ends up having different ERGs, I don't think we have the opportunity to talk about it here, but Zymergen has a women's plus ERG, a multicultural association, a rainbow group, so that it fosters a community where people can air a lot of these internal conflicts that they're having, so that it makes it a little bit easier. It definitely helps, because a lot to say about being underrepresented, and it's nice to have someone who can talk to you about that. I'll hand off to Alex.
Yeah, and one other thing to add is both Brandon and I are part of our DEI council as we think about how to enable a more inclusive community here at Zymergen. And it's not easy in a company that, there's a lot on our plates. We still need to become really, we're a long way to go to profitability. So how do you balance kind of short term, business needs with longer term, priority of developing a diverse community? So I think that trade-off of running fast versus running smart on this front is definitely tricky. One other thing I want to call out too is, for me at least, I'll never get a job through a family connection. That's just out of the question. And there's a lot of people who benefit from that. But I have, been fortunate to have mentors, similar backgrounds to myself, who realize, kind of we're in it together. As for me being the son of an immigrant, understanding that okay, I need to, I've benefited so much from people who have walked the path before me. And that's why I love giving these talks, to help people who are following, from STEM into these industries, leverage the kind of community of, diverse talent that's there, because we're all in it together. We don't have the uncle who'll be able to get us this, glorious internship just because he knows the CEO. We got to kind of work through things together as a community here.
Thank you, guys. These are some really important words, and I'm hoping that you guys would be open to, folks reaching out from MESA students, so that you can become those, or you probably already are, mentors to a number of folks. But your willingness to do that for students, I think, is going to be really critical. So let's see this video.
Yeah, and I imagine we'll share out LinkedIn information, et cetera, afterwards, Tom, and the platform for doing that.
That'd be great. Thanks.
Right. Let me share my screen. Our mission, last 2 minutes here.
They're just too small to see. Maybe that's why the old industry model has overlooked the most powerful manufacturing platform on Earth: life. At Zymergen, we partner with nature. We study it. We dream about it. And then we do incredible things with it. We watched the flutter of a dragonfly's wing. Now we're making more flexible phone screens. We learned how muscles stay stuck. Now we're making more effective adhesives. With yeast, like the yeast that makes food, we're making phone screens at scale, faster than the competition. We're developing bug sprays that are gentler on people, growing crops that feed themselves, training microbes to turn trash into treasure. The old industry giants tried to conquer nature. We work alongside nature at the most fundamental level with a proprietary platform powered by AI, machine learning, and automation. We give the world's greatest minds, one of the world's largest DNA databases, and the most advanced technology to reimagine the world, one molecule at a time. That's how we make better products. In half the time, at a tenth of the cost. Our microbes have delivered over 1 billion in product sales and counting. We're delivering to market faster, cheaper, and greener than anyone's ever done. Sounds like a miracle. It is. Zymergen.
So there we go.
That was great. Did you have a hand in that?
I did not, but there's a longer
Okay.
6-minute video that I believe Brandon stars in. So
Is this something that we could
yeah.
share out to the rest of our community on Jumpstart?
yeah,
Yeah,
it's
they seem
on the
to be
website. It's on the Zymergen website. So
Yeah, they seem to be
Simmons.com.
promo videos, so that's actually a very cool video to share. Thank you, guys. Do you have any final comments?
I think thank you for giving us a chance to talk about Zymergen, and thanks for all the questions. And feel free to reach out afterwards if anything else is top of mind.
Yeah, I think we had a student request the last slide from your presentation because it had like an all-in-one place of your internship process. So if you could share that with Danielle or me, and then we can send out a follow-up email through our Jumpstart platform to all the students who came, but yeah, all the students who signed up for this session. Thank you so much. It was a fantastic presentation. You guys have some really great insights in a broad range of topics. And I hope you guys enjoyed yourselves.
Thank you for having us.
Thanks, guys. This was great.
Thank you. Have a good weekend, everyone.
Enjoy your weekends. I'm going to stop.